Hey guys, Mr. Gran here with a challenge video for 8-6 day 1. Looking at simplifying some radicals with you making some factor trees that are going to be a little different than the ones that we did in class. Okay, so we are trying to simplify the cubed root of the square root of 27. Now if you want to try this on your own, pause it, but you might want to see how I do this one and then try it on the next one. Okay, so simplifying this. Now, even if we're not sure like what the answer is going to be in the end, one logical first step would be to start splitting 27 up into its factors. So 9 and 3. And you might even break that 9 down a little bit further, but I'm gonna not do that right now. Actually, yeah, you know what? I will do that right now. So that 9 splits into a 3 and a 3. Now what this means, what you might do then is circle 2 of these and write it as 3 root 3. And you're not wrong there, but if I look on the outside here, I'm really trying to get 3 of something through this square root. And so when I break down this square root of 27, I get 3 different factors to come out. Now, what's important here is when you do a factor tree, 27 is equal to 3 times 3 times 3, which we showed with the factor tree, but the square root of 27 is equal to the square root of 3 times the square root of 3 times another square root of 3. And so this could simplify then to the cubed root of root 3 times root 3 times root 3. And now that I've sort of broken down the square root of 27, now I'm looking for, to simplify this cubed root, I'm looking for 3 matching things. Well, I have 3 matching things right here. The root 3 times root 3 times root 3. So the cubed root of that product is going to be one of those square roots of 3. All right, so it's very similar with this one if you want to pause and try it on your own. All right, so 36 is a perfect square, but we're trying to do the cubed root of 36 and then take the square root of that. What I could do with this, again, is to factor it out to 6 and 6, right? And now the cubed root of 36 isn't 6 times 6, it is the cubed root of 6 times the cubed root of 6. And so this would simplify to the square root of cubed root of 6 times the cubed root of 6. Well, now if I'm taking the square root of everything in here, I'm looking for 2 matching things that are being multiplied together, and that is the cubed root of 6. So the square root of the cubed root of 36 is equal to the cubed root of 6. And if you check this with your calculator, you'd see that the decimal estimates for both of these, this one, the original, and then the simplified version are the same thing. All right, somewhat similar here. I would suggest if you're going to pause and try this on your own, make it one big rational first, or one big radical first, and then start to break things down from there. All right, so this one actually isn't too bad if we started out by changing it to this. And now one thing you could do is just plug this into your calculator and it'll be a nice whole number that you could then start factoring out. The other thing that we could do though, just for the fun of it, just to start really emphasizing the idea of what exponents mean and roots mean, 27 cubed means that it's 27 times 27 times 27, 3 total times, and 9 squared. Yeah, it's 81, but it's also 9 times 9, right? Well, now I can start breaking these down a little bit. Oops, that's not what I wanted. I wanted the highlighter. So this 27 over 9, that could reduce. And this 27 over 9 could reduce. And all of a sudden, these numbers are going to be a little less unwieldy. And that should be a negative in front of all of that. So this is going to be negative 5th root of 27 over 9 in the yellow highlighter would reduce to 3. 27 over 9 in the orange highlighter would also reduce to 3. And then one more 27. Now, I'm trying to get the fifth root of all of this. It's already partly factored. I could just continue factoring it by saying 27 is 3 times 9, and then 9 splits into 3 and 3. And so now I'm looking for 5 total things, right? Because 5 matching, like a product of 5 matching things, because I'm taking the fifth root. And so that would be 1, 2, 3, 4, 5 threes. So the fifth root, or the negative fifth root, would be negative 3.